All right, so this is the continuation of our notes from Conservation Momentum. You can see, yes, the Velocicoaster. That was an epic-ish video. I hope you all enjoy that. It seems like you all got a kind of a kick out of it, so yeah, kind of hope to go to there one day. We'll see what happens with everything going on, etc. So just a reminder, work energy theorem. Whenever work is done, energy changes. Work equals the change in kinetic energy, delta KE, which equals half mvf squared minus half mvi squared. Your total mechanical energy, or your mechanical energy, is always conserved. Remember we talked about how the energy before equals the energy after. Potential energy and kinetic energy, the initial ones, will equal the final ones. And also a reminder that your total mechanical energy, or ME, TME, will equal your potential plus your kinetic energy. So remember with this GIF, whatever. So as this guy is sliding, he's sliding down, 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 down. His speed increases, his height decreases. Now he's at height 0. He's at his highest speed. He's going back up. Notice how he's gaining potential energy. His kinetic energy is decreasing because he's slowing down as he's going up. He's at his highest point now. But notice the whole time, like we said, that it's the total mechanical energy is green. That the kinetic energy plus the potential energy in this system, in this situation, it's always going to be the same, the green one. It's the other ones that will change based on the height and the velocity of that person. Example number 3. A 74 kilogram student starting from rest slides down an 11.8 meter high water slide. How fast is he going at the bottom? So this is your mass starting from rest. So just to visualize it, you have this person on a slide, and he or she is starting from here, and it's 11.8 meters. Eventually, this person is going to slide all the way down. Well, how fast is he going at the bottom of the slide? Right about there. So how do we figure this out? We have to remember that my total mechanical energy equals my potential energy plus my kinetic energy. And I need to figure out how am I going to get that velocity by itself. Okay, so using this and knowing that my initial potential energy plus my initial kinetic energy will equal my final potential energy plus my final kinetic energy. So looking at this, I know that in the initial part up here, my velocity is 0 because I'm at rest. So this is gone. This zeroes out. When I'm at the bottom of the slide, my height is 0, so this is gone. So all I'm left with technically is mgi, or hi, equaling half mvf squared. I want to solve for the volume. So to solve for the velocity, the final velocity, oh, that's so silly. I'm going to solve for vf squared, like we did in class. So what I'm going to do is I'm going to multiply both sides by 2 over m. By doing so, this m and 2 will cancel out, and I'm left with 2 times mghi divided by m equals vf squared. My m's cancel out because I'm just dividing, and I want to take the square root of both sides. So the square root of 2 times 9.8 times 11.8 equals my VF. You'll notice that my masses don't matter in this situation. It's kind of crazy. The masses matter when we're doing the roller coaster thing in class, but notice when we're using this, the masses just kind of cancel out. So this 2.98 times 11.8. Take the square root of this thing. So when I did all of this, I ended up with 231.28. I'll take the square root of that, and I'm going to end up with 15.207 something. So then we can make this for my final answer. Sorry, this is really disorganized, but I'll take this all the way up here. 15.2 meters per second. All right, very good. Determine the mechanical energy of a 450 kilogram roller coaster at 30 meters per second at the bottom of the first dip, as well as 15 meters above the ground. So all of this it's kind of crazy because, like, how do you find the mechanical energy? Well, remember that your mechanical energy, the total mechanical energy, which is this, equals potential energy plus kinetic energy. You got to remember, you look at the problem. I have a mass, a velocity, and a height. So my total mechanical energy is mgh plus half mv squared. I'm just really plugging my numbers now. So 450 times 9.8 times 15 plus half 450 30 squared. So 450 plus 9.8, sorry, nope, 450 times 9.8 times 15 plus 0.5 times 450 times 30 squared. So I end up with 268,650 joules. That's supposed to be a capital J. All right, so this example 5 is in 3 parts. Same. Sorry, it's kind of mean. So Julia has a mass of 49 kilograms. Boom, mass. What is her potential energy standing on the 6 meter diving board? Let's say she is 6 meters above the water. So letter A, I'm trying to find my potential energy. Here's my height. Potential energy equals mass times G times H, 49 9 times 9.8 times 6. 49 times 9.8 times 6. And I'm just going to put all the numbers I have in this one. So 2,881.2. So we can actually just make this 2,881 joules just to make it easier. What is her kinetic energy just before she hits the water? So remember, let's see if I can draw on this GIF. So let's see. There you go. There, and then boom. So if this is her highest point at the diving board, this is her lowest point right before she hits the water. So remember that in this one system of her going from here to here, because if she follows it, not too bad. It's pretty good. We're assuming that her energy is completely conserved. So that means that if her potential energy is 2,881 joules at the top of her highest point, right before she hits the water, her kinetic energy would actually be 2,881 joules because of the fact that now when she hits the bottom of the water, or the top of the water, I guess, her height is 0 meters. So therefore, no more potential energy. She has all kinetic energy. What is Julie's speed after she hits the water? Just as she hits the water. So this is her velocity. We have her mass. So we have her kinetic energy from before, 2,881 joules. Let's just use that number. That's fine. kinetic energy equals half mv squared. What I'm going to do is kind of rewrite this differently, kind of like in your other video. So mv squared divided by 2. I just distributed a half. I want to solve for v. Multiply both sides by 2 over m. That cancels out. I'm left with 2ke over m equals v squared. Take the square root of both sides. Square root of 2 times 2,881 joules divided by my mass of 49 to get me my velocity. 2 times 2,881 divided by 49. Take the square root. Oops. And take the square root of that. I should end up with a velocity of 10.84. Ugly. 10.84 so it's going to be about 10.8, oh my lord, 10.8 meters per second. That's her velocity as she hits the water. Alright guys, so that's it for this video. Let me know if you have any questions. Thanks.